Alright folks, here we are back in PyCharm. In the last video we kind of covered how to count or how to convert binary into decimal characters and how the computer kind of does that. We're going to use some of the same concepts here in Module 5 to explain how Python compares strings together. Now in Module 5, the example that gave me heartburn was this lowercase beta is greater than the uppercase beta. And while the other ones made sense, we can kind of see if the strings are the same, we know that they're equal to each other. If the strings are different, we know they're not equal. But the greater than and less than is confusing. And I think naturally you would assume that the one with the capital letter is greater than the one with the lowercase letter, but that's not the case. And here we'll define some functions to show you how Python determines which strings are greater than the others. So, oh my goodness. I'm going to define a function and pass it a string. In this function, we're going to declare an empty list. And then what we need to do is remember that Python sees strings just like it sees a list, and that means that you can grab just one character out of that string if you know its index. Just like a list, you can grab one element out of that list if you know what the index is. So with a list, we iterate through it to do something on each item in that list, and we're going to do the same thing with a string. So we're going to use a for statement, and for each element in the string, we're going to do something. In this case, we are going to append the result of the ORD function to the decimal list. And then we want to print that decimal list so you can see it. So this function here, ORD, will convert each character in the string to its decimal counterpart. And if we call it and pass it a variable, pass it a string, we run it, we can see that it converted each letter in beta to its decimal counterpart. If we check our handy dandy chart, we'll see that the capital or the lowercase b is 98, the E is 101, the T is 116, and the the A is 97. Good Lord. So we know it works, and that's how Python sees the strings, by its decimal counterparts. So if we pass the uppercase beta and run that, we'll see we can compare the lists, and we see the difference is 98 and 66, this being lower than this, the capital B being lower than the lowercase b. So you could total these up. Let's do that real quick. Define a variable to hold the total, blank it out, and then for each item in the string, we're going to increment that total by the result of the ORD function run against each element in the list. Run that. We got to print it. I always forget something. So we can see that the total, obviously, the number's lower, so the total is going to be lower. The total is 380 for the capital B and 412 for the uppercase B. But we know that Python goes to the first different character. So let's look at words that are similar and run this and see what happens. We can see here that these totals are the same because the letters are the same. So the totals are the same. So wouldn't you think, based on the totals, it would say they are equal to each other? Let's see this in action. If perfect is equal to prefect. Print true. Else print false. And run that, and we can see that ain't right. No, it's because I wrote the same word twice. Goodness gracious. Perfect and perfect. All right, now it's false. Obviously, the numbers are still the same. Obviously, it was the same before. It was the same word. But now I did switch these up. So you got perfect and prefect. Perfect and prefect have the same total value, but they are not equal to each other, because Python goes to the very first one that's different, which in this case is the E and the R, and it looks at the R and says that value's higher. So therefore, prefect is greater than perfect. Well, let's see if that works. Yep, it returns true. So that's how Python is comparing strings. Now let's see a couple of other functions that you may find useful. Let's define a function to convert this to, let's go to hexadecimal. If you've taken my other Intro to Cybercrimes course or any computer forensics courses, you'll see that you use hex a lot, so this may come in handy. But you can't pass, so the function that works to convert to hexadecimal doesn't work with string variables, it works on decimals. So what you have to do is basically the same thing you did in the decimal function, but then add an extra step. So we'll go ahead and do this just like we did in the other. And then so just like any other one, we're going to append the value of ord to a list, and then we're going to pass that list for each one of those elements in that list that we created. We are going to append the value of this function hex to the hex list, and then we'll want to call that or print that. And we'll call that function both of these. Run it, and you see you get a list with the hexadecimal values for each character in the string. This 0x, this tells you it's a hexadecimal 62 as opposed to a decimal 62, and that's important because if you go refer back to your list and you start looking at these numbers, the hexadecimal 62 is a B, but it goes 64, 5, 6, 7, 8, 9, and then it doesn't go to 70, it goes 6A, 6B. So you will oftentimes see letters in here. It's not a decimal 62, but a hexadecimal 62. And what if we want to convert to binary? Oops. So if we're going to go to binary, well, there's an extra step we have to take because it will not recognize a string. So you have to turn it into a byte string. So first let's declare our list, our empty list, and then convert it to a byte string or binary string list. Here we go. and you use the byte array function on the string passed into the function and encode it in UTF-8. Or it is encoded in UTF-8. So that one little line makes the difference, and then you kind of go for byte in the binary list. In the binary string list, we're going to do something. So not in the string byte list, but in this binary string list, because we converted the string that was passed to the function to this variable here. And then we are going to append the bin function, the result of the bin function, as it's been run on each byte in the binary string list. And we'll print that byte list. And then we need to call it. And run it. And here you go, the binary representation of each of the characters in the string. And it is prefixed by this 0b, so you know it is binary representation. It's not a decimal number. That's kind of a big mistake to make. What you'll notice here, though, is that you're only getting 7 characters. 1, 2, 3, 4, 5, 6, 7. Yeah, it removes the zeros at the beginning of it. If you want to make that look a little bit more like what you would see, let's do this. I'm going to change that list, and we'll make this a string. An empty string, right? We can't append to a string. Or, yeah, we can't append to a string, but we concatenate with a string, right? So we're using a string now instead of a list, so we concatenate the result of each of these calls for each byte. Let's see what that looks like. And that puts it all together. So you see some binary. You still got these 0b's in here that don't need to be there. Let's get rid of those. You may or may not have covered this in strings, but here's remove prefix. It's a method for strings. There you go. All those are gone, but we're still lacking. There should be 32 bits here, right? Well, I'm not going to count them all. We need to put that 0 in there if we want it to be accurate. I'll let you figure that one out on your own. That, I think, covers what I wanted to show you. So you've got the ORD function, the hex function, this byte array for converting strings into binary strings, and the bin function. With this, you could probably create a nice little decimal to hex to binary calculator that you see on the internet or other places. You could probably do that pretty easy. So you may see this stuff again. If you have any questions, shoot me an email. I hope this sheds some light on something. Thanks.